Greetings. In this video, we're going to be taking a look at the handout Practice with Fractions for Math 105 Intermediate Algebra. Now, the reason we even bother with this particular handout is that in this class, you need to know how to simplify, add, subtract, multiply, and divide fractions, and basically just be able to do operations on fractions. So, we're going to use a handout found on our Blackboard page. So the first thing we want to do is identify where this is. So on our Blackboard page, if we go over to the left and scroll down, we can click on Module 1 Handouts. This will take us to the handouts that we need for our first exam, and at the very bottom here, we see Practice with Fractions. Once you click on this, this will allow you to download this particular Word file, and remember, if you need a different format, all you need to do is come next to any particular download, click on the A with the upside down arrow, and this will allow you to choose a different format. So once you download this, and it would be in your best interest to see if you can actually print this off, but it is not required, by the way. We can actually start working with these particular problems. So once again, we're going to deal with warm-up practice with fractions, and let me move over to my writing station. So what we're going to do is learn how to simplify fractions. And again, these are skills that you're actually supposed to have before you come into the class, and this is only going to be a brief review. If you do not know how to deal with fractions, simplifying, adding, subtracting, multiplying, dividing, I suggest you immediately go and learn how to do so. So the first problem we're going to look at for number 1, simplify each fraction. In other words, write each in lowest terms. When we say simplify or lowest terms, they mean the exact same thing. So here for A, we have 28 over 36. Now there's going to be multiple ways that we can simplify our fractions, and all of them are going to be legit as long as you are doing them correctly. But I'm going to show you 2 distinct ways. First is going to be the longest method, which is going to be dealing with using a factor tree to break down numbers. So what we can do is take a look at our numerator, which is the top of the fraction. And we can also take a look at the number in the denominator, which is the bottom of the fraction. We just need to know these 2 terms because all fractions will have a numerator and denominator. So by taking the number in the numerator, number 28, something we can do is use a factor tree to break this down into its prime factorization. This is just a fancy way of saying we can actually rewrite the number 28 as a bunch of prime numbers that are being multiplied together. So with a factor tree, this just means it's going to branch off in 2 directions. We need to use 2 factors, 2 numbers that when we multiply them together, give us 28. So in this particular case, we could use 4 times 7, that is 28. We could also use 2 times 14. That would also be 28. It does not matter which pair of factors you use, you'll get to the same answer anyway. So let's use 4 and 7. So the idea of a factor tree is that we want to break down this tree until we run into prime numbers and cannot break it down any further. So a prime number just means there are no 2 integers that we can multiply together to get a number except 1 in itself. So what we see here is number 7 is actually a prime number. The only 2 numbers we can use to break down this number are 1 and 7 itself. So I circle this to let myself know, hey, we are done with the number 7. So in our final answer, there will be a multiplication of 7. On the other side of this tree, we have 4. Well, this can break down into 2 times 2. 2 times 2 is 4. And the same thing here. If we want to look at 2 individually and try and break that down, the only 2 integer factors we can use would be 1 and 2. Therefore, 2 is a prime number. So what we see here is any number that is circled, and we cannot continue the factor tree anymore, if we multiply them together, that will give us 28. So we can rewrite the number 28 as 2 times 2 times 7. So let's go ahead and do that. I'm going to replace my numerator here with 28 with my prime factorization of 2 times 2 times 7. So what we're going to do now is the exact same thing, but now we're going to do it for the number in the denominator. So we're going to use a factor tree to break this down as well. And again, there's many factors we can use. We could do 4 times 9 is going to be 36. You could do 12 times 3. You could do 18 times 2. There's a lot of factors you can use. It does not matter which pair of factors as long as they multiply together to give you 36. So in this case, why don't we actually use 12 and 3? Again, we'll just use some different numbers here. So when we take a look at number 12, we can break this down even further. So again, this can either be 3 times 4 or maybe even 2 times 6. It does not matter. You'll get the same answer. So 12 breaks down into 2 times 6. 2 is a prime number, so I'm going to circle it to make sure I know I'm done. 6 breaks down even further into 2 times 3. 2 is a prime number, and it turns out 3 is as well. So what we see here is we have broken down the tree as far as it can go, and we're left with just prime numbers. If we multiply what we have in the circles, we get 36. 2 times 2 is 4, times 3 is going to be 12, times 3 is 36. So this means a different way we can write the number 36 is 2 times 2 times 3 times 3. So this means I can take the number in my denominator, number 36, and I can rewrite this as its prime factorization. 2 times 2 times 3 times 3. Now, the whole point of this problem is to simplify our fraction down into its lowest terms, which means we want to rewrite the fraction as a different set of numbers that represents the exact same number. So what we are allowed to do in a math class is cancel prime numbers, and specifically if they are factors. So we can actually cancel any factor in my numerator with a factor in my denominator as long as they match. So what do I mean by that? Well, I see a 2 here in my numerator. I see a 2 in my denominator. We can actually cancel these factors, and all canceled factors cancel to 1, not to 0, not to a blank space. So here I was able to cancel a factor of 2. Well, when I look, I see we've actually got another factor of 2. So we can actually cancel these factors of 2 as well. The only thing that we are allowed to do is cancel the same factors. So I see I've got a factor of 7 on top, I've got a factor of 3, and another factor of 3 on the bottom. We do not have any canceling factors. We cannot cancel them out, which means we must keep these factors. So when we are done canceling our factors, we simply multiply what we have left in our numerator. In this case, it's going to be 1 times 1 times 7. That's going to give us 7. And then we multiply what is in our denominator. 1 times 1 times 3 times 3 is 9. And by definition, this is the same fraction, 28 over 36, what it would be in its lowest terms. In this class, you are going to be required to simplify all fractions. Make sure you know how to simplify your fractions. So this is the longest drawn out way and how to do this by using a factor tree. I recommend this if you just are not good at factors or not good at fractions at all. So another way we can do this, and it's probably the way most of you know, is we can use divisibility. So let's rewrite the same problem, 28 over 36. What we can do here is look to see, are these two numbers in my numerator and denominator divisible by any of the same numbers? So what I mean by this is we can take a look at all the factors of 28 and see, do we have any factors that cancel? So that's what we did over here, but now we're going to use divisibility. So in this particular case, I know that 28 is the same as 4 times 7, and that 36 is the same as 4 times 9. Notice that they have the same factor of 4. These are both divisible by 4. So what we can do is actually divide the top and the bottom by 4, and we're allowed to do this because 4 divided by 4 is equal to 1, and 1 times anything is itself. So using divisibility, I can take my numerator, 28, and divide this by 4. That will give me 7. I can also take the denominator of 36 and divide this by 4 to get 9, and what we see is the exact same answer coming back. So this is how we can also simplify using divisibility. The final way that I'm going to show you is still using divisibility, but it's probably the method in the visual that you've seen growing up. So here, if I just rewrite it one more time, 28 over 36, what I can say is both of these numbers are divisible by 4. So what I can do is say 4 goes into 28 7 times, 4 goes into 36 9 times, and what we have left is once again 7 over 9. So these are just two methods on how we can simplify fractions. And in this particular case, they are not the only two methods that you can use. It is all right if you have your own method of simplification as long as it's a legitimate mathematical way to do so. And a reminder, once again, every fraction in this class that can be reduced, you will be required to do so. So knowing your simplification is going to be very important. So let's go ahead and take a look at the next problem, 99 over 21. So in this particular case, I'm going to rewrite the problem, 99 over 21. We now have two methods to do this. You can either break down each one of these numbers in the numerator and denominator into their prime factorization, or we can use divisibility. We will stick with divisibility as this is an accelerated math class, and you are actually already expected to know how to do this. So when I take a look at these two numbers, 99 and 21, I notice that both of these numbers are divisible by 3. 3 goes into 99, which would be 33 times, and 3 goes into 21, which would be 7 times. So using our divisibility and cancellation method, the final simplified answer that we need here is 33 over 7. And I know that's the case because 7 is not divisible with any other number with 33. And we can even prove this by using the first method we actually showed by breaking down both of these numbers into their prime factorizations. So 33 is the same thing as saying 3 times 11, and 7 is already prime. And what we see here is there are no factors that we can cancel from the numerator and the denominator. So this means our final simplified answer would in fact be 33 over 7. All right, so let's take a look at the final problem here. In C, we've got 3 over 31. So one of the hardest things about fractions and simplifying is knowing when to stop simplifying. In this particular case, when I take a look at these two numbers, 3 and 31, both of these numbers are already prime. If they are prime numbers, that means we cannot break them down into factors, and specifically any factors that can cancel. So that means here, 3 over 31 already is simplified. This is as low terms as we can place them. All right, so just make sure that you understand how to simplify your fractions because once again, you're going to be required to simplify all fractions in this class. So now what we can do is scroll down here and take a look at example number 2. Evaluate and simplify the following expressions, reduce fractions to their lowest terms. So this is going to be dealing with addition and subtraction of fractions which have completely different rules. So what we can do here is write our problem. 5 over 8 minus 1 over 8. In order for us to add or subtract fractions, we must have a common denominator. In other words, what number or even factors or variables, because it will be more than that coming up later in this class, has to be the exact same thing. So what we see here in these two fractions, we do have the same number of 8 in our denominator. So when we add and subtract fractions, we are required to have the same denominator. And if we do have the same denominator, when we combine them together, my answer must keep that denominator. Notice we did not go 8 minus 8 is 0. What we are saying is whatever it takes to complete one thing requires 8 pieces. I have 5 of them, and I am take away 1 of the 8 pieces that would require the same thing. So that means here in the final answer, we still have one full thing requiring 8 pieces. So our denominator just stays the same, and then all we need to do is the operation in our numerator. So here we're going to take 5 and subtract 1. Well, 5 minus 1 is going to give us 4, and we get an answer of 4/8. However, you are required to simplify all fractions in this class. And I can see 4/8, both of these numbers are divisible by 4. 4 goes into 4 one time, 4 goes into 8 2 times, which means our final simplified answer actually simplifies down to 1/2. And 1/2 is the answer that we would need to get full credit. So let's go ahead and take a look at the next problem. Here, I'm going to go ahead and actually get rid of my papers and start brand new. So what we're going to do in this problem, excuse me, I shouldn't be walking away from my microphone like that. What we're going to be doing in this problem is seeing what happens when we have denominators that are not the same. So the problem that we have is going to be, and I need to scroll down on my other computer here, 3/4 plus 7/9. When we add and subtract fractions, we are required to have the same denominator. And in this case, we do not have the same denominator. So what you need to do is force it to have the same denominator. Our answer here is not 10/13, and in fact, you would lose all your points because that is considered a fundamental math error. Instead, what we need to do is get the denominators to be the same number, and to do that, we need to find the least common denominator. And in math, we literally just abbreviate down to the LCD, the least common denominator. Now, we do not have time in this class to actually teach you the least common denominator. And once again, you're actually supposed to know this coming in. So if you have no idea what a least common denominator is, you should stop this video, go on to YouTube or Google or wherever and learn how to do it, because it is going to be required to add or subtract any fractions in this class. And we're going to be doing that quite a bit. So when I take a look at these two fractions, we take a look at our denominator here, which is just going to be 4 and 9, and we want to find the least common denominator. So in this particular case, what we can do is say that the least common denominator is going to be 36. There are many ways to find this, and one cheat way to do this is literally just take the multiples of the number. So in this case, all the multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, 36, and that would go on from there. We can do the exact same thing for the second number in 9. We will have 9, 18, 27, and 36. So a cheap way to find the least common denominator is to write down all of its multiples and then simply find the lowest number that they have in common. And in this case, that ends up being 36. So that is why our least common denominator is 36. Now, the reason we find the least common denominator is this is the number we want to change each of our denominators into. I want to change the number 4 into 36, and I want to change the number 9 into 36. Well, how can we do that? Well, to turn a 4 into a 36, we simply need to multiply it by 9. 9 times 4 is 36. However, we can't just multiply the denominator of a fraction. We must also multiply the numerator of the fraction by the exact same number. And the reason why is 9 divided by 9 is 1. 1 times 3/4 is still 3/4, so we're not changing the number. We can do the exact same thing to the other side. We need to change 9 into 36. We can do that by multiplying 9 by 4. And the same thing, we need to multiply the numerator by the same number as well. So if I simply multiply both of these fractions by their version of 1, what we're going to see is that our denominators will turn into our least common denominator of 36, and then we can actually add them together. So how we multiply fractions is very easy. We simply, to get our numerator, multiply the two numerators together. 9 times 3 is 27. Then, to get our denominators, we simply multiply the two denominators together. 9 times 4 is 36, and that's exactly what we were trying to get. That is what our LCD was. We still have addition in the middle, so we need to keep that. And then we multiply these two fractions. 7 times 4 is going to be 28. 9 times 4 is 36. So what we've done here is simply rewrote each of our original fractions into what are called equivalent fractions. That just means they are the same fraction, they represent the same thing, but they were rewritten slightly different. From here, now we can apply our rules. In order for us to add or subtract fractions, we must have the same denominator. That means here, when I add these two together, we must keep that denominator of 36, and then we simply go ahead and add my two numerators together. 27 plus 28 is going to be 55. And then from here, we would look to see if we can simplify these fractions any further. And in this particular case, we cannot. And you can prove that to yourself by breaking these down into their prime factorizations. 55 is 5 times 11, and 36, we actually already did this, is going to be 2 times 2 times 3 times 3. We can see that none of these factors are the same, and therefore we cannot cancel. That means our final answer, in its simplest form, is in fact 55 over 36. So once again, when we add or subtract fractions, whether we are dealing with numbers or variables or even factors, and we're going to see this a lot in exam number 2, you are required to have the same denominator. Now this works the same way for subtraction as well. So what I'm going to do is I'm going to leave you problem C to try on your own, and it will follow the same rules that we have here. So let's go ahead and scroll down, and we can take a look to see when we multiply and divide fractions. So it turns out multiplication and division of fractions is actually much easier than addition and subtraction. With addition and subtraction, you are required to have the same denominator. With multiplication and division, you actually do not need the same denominator. So let's go ahead and take a look at our next problem here when I scroll down on my other computer. For D, we have got 7 over 16 times 8 over 21. So when we want to multiply fractions, we simply just need to multiply my two numerators together and then multiply my two denominators together. The problem with just doing it straightforward is that we can end up with some big numbers. So 7 times 8 is 56. That's easily, we should know our multiplication tables. And in fact, I'll even let you know right now, you have to know your multiplication tables 1 through 10 times 1 through 10 in order to be successful in this or any other college math class. But going back to this problem, if we try and multiply 16 times 21, well, we can do it, but we're going to end up with some bigger numbers. So the trick is we actually want to simplify first before we multiply our numerators together and multiply our denominators together. So what we can do is take the same methods that we saw in the original problem that I showed. So just going back to that problem, what we can actually do is just cancel like factors, or we can use divisibility in anything we see in the numerator and the denominator. So in this particular case, what I'm saying is I see I've got a 7 on top, and I've got a 21 on the bottom. Notice it does not need to be in the same fraction because we are multiplying these. So what I can say is 7 and 21 are both divisible by 7. 7 goes into 7 one time. 7 goes into 21 3 times. And what this is going to do is make the problem easier when we multiply these together. But we can keep going. I see a 16 on the bottom, and I see an 8 on the top. Both of these are divisible by 8. 8 goes into 16 twice. 8 goes into 8 one time. And now when we take a look at the numbers we have left, and again, reminder that these cancel to 1, not to nothing or 0. All we need to do to find our final simplified answer is multiply our numerators together to get our numerator. So we're left with 1 times 1 is 1. And then multiply our denominators together. 2 times 3 is 6. And there it is. This is our final simplified answer when we multiply 7/16 times 8/21. We end up with 1/6. So multiplication is actually easier than addition and subtraction, but the trick is we want to try and simplify first before we start multiplying, because we can end up with some bigger numbers, which will be even harder to try and simplify down. All right, so let's go ahead and take a look at a division problem. And it turns out division is not something we do with fractions. And in fact, to divide fractions, we simply multiply by what is called the reciprocal. So maybe I'll even put it down here. The reciprocal. This is a word that you're going to be seeing quite a bit, and you're actually going to be using the reciprocal quite a bit. So a reciprocal just says that if I've got a fraction in the form a over b, one number over another number, if we want to find the reciprocal, all we need to do is take these two numbers and flip them over. So that means the reciprocal of a over b is simply b over a. And this works with negative values as well. Let's say we have the opposite of a over b. If we wanted to find the reciprocal of the opposite of a over b, we still just take the fraction and just flip it upside down. This is still the opposite of b over a. So when it comes to the reciprocal, we use this when we divide fractions. So once again, let's go ahead and write out our problem. We have 7 over 9 divided by 1 over 3. So here, we don't actually divide fractions, we multiply by the reciprocal. So what does this mean? We keep our first fraction exactly the same. We don't touch it. We leave it alone. This is still 7 over 9. Then we are going to take division, and we are going to turn this into multiplication. And then the final piece is we take our second fraction, and we find its reciprocal, which just means we take it and we flip it over. So the reciprocal of 1 over 3 is 3 over 1. And this is the trick to dividing fractions. We don't actually divide fractions. We multiply by the reciprocal of the second fraction. And then all we need to do is simplify just like what we did up above. You can multiply this straight through, but you still want to see if you can simplify first. And we can. I see a 3 on the top. I see a 9 on the bottom. Both of these are divisible by 3. 3 goes into 9 3 times. 3 goes into 3 1 time. And now all we need to do to get our final simplified answer is multiply my numerators together. 7 times 1 is 7. And then multiply my denominators together. 3 times 1 is 3. So we end up with the improper fraction 7/3. Now, in this class, it turns out we don't have to turn numbers into mixed numbers. We are allowed to keep them as proper and improper fractions. Now, you're not going to be marked incorrect if you do change it into a mixed number, but that is just more work that you don't need to do. So here, we are absolutely okay with leaving our answer as the improper fraction of 7/3. But if you are so inclined, this is also the same as 2 and 1/3. The one thing we don't want to do in this class, unless it is specifically told to do so, is use decimals. Decimals are nice, especially in the real world, but they are approximations. When we are dealing with exact numbers, that's what we use fractions for. 7/3 is an exact number, where if we tried to take this as a decimal, this would be 2.333333, repeating forever. This is an approximation. So once again, in this class, when we simplify our fractions, we're allowed to keep them as improper and proper fractions. All right, so let's take a look at one more problem here. So on our handout, there was a couple more on our handout, but that's okay. We're actually just going to take a look at this next problem, just so we understand one concept about fractions. So here we can go ahead and take a look at F. We get 2 over 15 divided by 8. So what we need to understand that in a math class, there are redundant pieces that we don't write. So let's just take a look at a variable. In this case, let's use the variable x. X has a lot of hidden information that we simply don't write. So for example, we have a coefficient of 1 out in front of x. We simply just don't write a multiplication of 1 because 1 times anything is itself. This is also a fraction divided by 1. We simply don't write it because anything divided by 1 is itself. But we can even take it further than this. This actually has an exponent not written. It's implied to be an exponent of 1. We also have addition and subtraction not written. We can add or subtract 0. And the final piece, and this will come up in the third exam and is a little ridiculous, but this actually is a radical as well with an index of 1. But the point of this is every number and every variable actually is a fraction over 1. So when it comes time to reading this problem, we don't have 12/15 divided by a single number. What we actually see here is two fractions being divided because 8 is a fraction over 1. So this means all we need to do to solve this problem, I should say simplify, is that we just need to multiply by the reciprocal. We keep our first fraction the same as 2/15. We are going to change division into multiplication, and then we are going to take the reciprocal of our second fraction. We're just going to take this fraction and literally flip it over. So this now becomes 1/8. And now from here, we can go ahead and simplify this in whatever method you choose to simplify. So in this case, I see a 2 on the top. I see a 8 on the bottom. Both are divisible by 2. 2 goes into 2 one time. 2 goes into 8 4 times. And now all we need to do to get our final answer is just multiply my numerators together. 1 times 1 is still 1. We don't get rid of the numerator just because we canceled things out. We still have a 1 up there. And then 15 times 4 is 60. And this would be our final simplified answer. So what we have done here is we went through and we talked about how we can deal with fractions. Fractions is something that you will not be able to escape in this class, and you must be very proficient in dealing with them. So not only simplifying, but we need to add, subtract, multiply, and divide. And eventually, especially when we get to exam number 2, which is just our second week in this class, we are going to be dealing with variables and factors. So in order for us to add and subtract anything with factors or variables in the denominator, we must find that least common denominator. But fear not, we actually do have lecture videos that is going to deal with this exact thing. So my final piece of advice to you is that if you do not know how to work with your fractions or are abysmal, you need to go and learn them immediately, because if you do not know how to work with the fractions in this class will be extremely difficult for you to deal with. All right, so this has been the video, and I don't think we have anything in our outro. Yeah, there's nothing over here that I need to actually explain. This has been working with fractions. And a reminder, this is not graded. You do not need to turn this in. This is just a reminder that we have to be good with our fractions. I will see you in the next video.